its continuous operation. In the chokes, we can install the corrosion monitoring devices, right? The different type of chokes, and they are just installed the corrosion monitoring devices, right, at different places. The corrosion monitoring location for the main line, which are cross-country line, which are usually quite big lines, right? Generally about 20 inches diameter. Sorry. Where if the pipelines are always put underground. For underground pipelines, we need to have a underground pit, right, as you see in there. And then we have install the boot in there. In the boot, we can install different type of corrosion monitoring devices. And this boot has to be, right, emptied from time to time. And at least when the people, they go for the corrosion monitoring, because mainly we install the ER probes in there. So we have to eject entire liquid from there, right, to make sure that the people who are working there, they are not subjected to any kind of right hazard situation. And at the same time, people in there, they monitor the actual corrosion readings. And we always prefer to have 2 safety valves there, not one. In case the one is plugged, right, or one is stuck, so we can easily, right, close the other valve. And when the people, they take the reading and they have to empty this one, the boot at the bottom, they have to close these valves to make sure that no gas or any crude oil, any other hazard liquid can escape from it. This is also the actual flow line installation of the corrosion monitoring device at different places. This is through the bypass. This is a main line. It all depends on what the people or the engineer decide to go for. Should they go for a bypass where they should install the equipment or the corrosion monitoring hardware, or they should install the corrosion monitoring hardware right on the flow line? It all depends on the engineers or the designer at the stage they are designing the system. This is another issue of the corrosion monitoring location on the pipelines, right, which is better and more clear picture given in there. The most critical part of the installation of the corrosion monitoring devices is on these pipelines, right, which are coming from top to bottom or bottom top. They are slanting in nature. So where to install the corrosion monitoring probes on these devices? So these devices are actually installed at these places where there is a full bore flow of the liquid. If the pipeline is flow is coming from top to bottom, the same is true if the flow is going from bottom to top, even then this side of the wall is always right covered with water. Side stream corrosion monitoring hardware. This is another way of installing our corrosion monitoring devices. Then to install it on the actual main equipment on the main line, we just can have a side stream by the different right facilities install different type of probes and different type of corrosion monitoring hardwares, and it can go up to the pressure of right low pressure, high pressure fittings are also available. So it will be between the upstream and downstream with flexible hoses. So this is another technique that we follow it in the industry. Instead of disrupting the main process, we just install the side stream facilities there, and in there we install the actual corrosion monitoring hardware. This is the shape of the 2-inch high pressure access fittings, the hollow and solid plug mounting assemblies. These are the 2-inch high pressure fitting, right? They are the welding, they're designed for different welding type and right, but they are mainly in the same pressure rating, regardless of what they look like and how they're designed at the bottom for the welding purpose. These are the actual hollow plug assembly mainly used for the installation of the coupons or the sand probes, and the solid plug assemblies, right? Sorry, the hollow plugs are used for the ER probes and LPR probes, and for the sand probes. Solid plug assembly is used mainly for the coupons installation. And these are two different techniques. Here, the system can pass through the hole in there. Here, the hole is actually blocked. So the device has to be fixed over here. And then these devices are installed into one of these access fitting, which already welded to the pipeline, right, for monitoring the corrosion rate. The corrosion coupons principle and monitoring principle is this a physical technique. It's not something chemical, electrochemical, or any other technique. It's just a simple physical technique. It's a direct, intrusive, offline technique. Means you cannot measure, right, the corrosion losses or the actual condition of the probes online. So the probe has to be taken out. And how the probe can be taken out, we can use actually the retrievers and the retractor online to take the coupons out. But still, it has to go to the laboratory for the analysis. Then the metal loss weight, metal lose weight when undergo corrosion, and start also these inhibitors or the coupons, they give the indication that how much could likely to be the corrosion rate at the surface of the structure or the pipe metal, but not exactly what may be happening at the pipe surface or the structure surface. This is a relative technique which can give you that how the corrosive condition of the fluid or the environment or the electrolyte that may be behaving and changing with the changing in the processes, depending upon how long you leave those coupons in there. Now, installation of coupon is very, very critical, right? Where the coupons are to be installed parallel to fluid flow. If you install these coupons perpendicular to the fluid flow, then the coupons will be subjected to the fluid impacts, and it can cause extra corrosion due to erosion, right? And due to other flow regime disturbances in there. This technique monitors weight loss. It can also use stress-assisted corrosion by installing stress probes or stress coupons, right? It can also measure the bimetallic corrosion. It can also indicate the differential ration in there. If there is a right entry of the oxygen in there, we can change the corrosion rate. It can also be used as the heat affected zones. You can have the probes which are suffering, which are welded and they are subjected to the heat affected, can be installed in there. Sensitivity of this technique is about 0.1 millimeter per year.